Okay, here's problem number 25 from homework 33. So we are looking to find the increasing, decreasing intervals, local maxima and minima, and intervals of concavity and inflection points for the function f of x is equal to x to the fourth e to the negative x. So first step is find f prime. F prime, product rule, first times the derivative of the second plus the second times the derivative of the first gives us that. I need the critical points, that's step 2. Critical points, there are going to be no DNEs because there's no denominator, no square roots, nothing like that where f prime could be a DNE. So I take my f prime, I'm just going to factor it while I'm rewriting it, and we're going to set that equal to 0. Set f prime equal to 0. Always factor if you can, because then that's going to help you find the critical points. Critical points, we have now 3 factors, right? We have x cubed, we have e to the negative x, and we have negative x plus 4. So we set each factor equal to 0 and think about if that has a solution. So x cubed equals 0 means x equals 0. E to the negative x equals 0 has no solution because, as we discussed in class, e to the negative x looks something like that, right? It never hits 0. So no solution, and the last one, negative x plus 4 equals 0, negative x equals negative 4, x equals 4. So I have these 2 critical points at 0 and 4. So my step 3 now is to put them onto a number line. So let me go ahead and do that off to the side here. So I take my points that I found and I put them, step 3 is put those critical points onto a number line. So 0 and 4. And I have basically 3 intervals that I need to think about. The blue one, the green one, and the yellow one, okay? Okay, so next step is our test points. So test points, I'm going to take my f prime equation, not the f equation, but the f prime, and I want to do some test points. Negative 1, I think, would put me in the blue interval. F prime of 1 would put me in the green interval, and f prime of 5 would be a nice convenient point in the yellow interval. So now you can use either the factored form or the original form of your f prime equation. So I'll go with the original form, and the first f prime of negative 1 would be negative. Be careful here, negative 1 to the fourth, e to the negative 1, which is positive 1, plus 4, negative 1 cubed, e to the 1. And so I'm going to get out of this, I think, negative e minus 4e, and that makes negative 5e. So that this is telling me that throughout this blue interval, my f prime is negative. Testing now the other interval, the test point in the green interval, f prime of 1 would be equal to negative 1 to the fourth, e to the negative 1, plus 4 times 1 cubed, e to the negative 1. So I'm ending here with negative 1 over e plus 4 over e. In other words, the denominator here is the same, so it's really 3 e to the negative 1, or 3 over e. And this is now positive in the green interval. And in the yellow interval, I can do 5, for example. So negative, 5 to the fourth, e to the negative 5, plus 4 times 5 cubed, e to the negative 5. So this is going to give me, basically, it's going to be e to the negative 5 times negative 5 to the fourth plus 4 times 5 cubed. And if you think about that a little bit, or if you do it with a calculator, you're going to realize that this is less than 0, because negative 5 to the fourth is a bigger negative number than 4 times 5 cubed. So this yellow interval f prime is negative, and so overall we now have that f is decreasing, increasing, decreasing. That means I have a local minimum here, a local maximum here at 4 and a minimum at 0. So we can write the answer to part A as increasing on 0, 4 and decreasing on negative infinity to 0 union 4 to infinity. Part B is about the local maxima and minima. Now, so here, I didn't have time to do this in class, but we really should find the y values, right? We know that the local minimum is at x equals 0. We'll do f of 0 back to the original equation, 0 to the 4th, e to the 0. This gives me 0. So 0, 0 is my local minimum. And then I have to find my local maximum, which will be at x equals 4. And so I do f of 4. So I'm going to get 4 to the 4th times e to the negative 4, which is 64 divided by e to the 4. So I can say that my local minimum, we can say it like this, local min at f of 0 equals 0, or you can think of it as a point 0, 0, and local max at f of 4 equals 64 over e to the 4th, or 4 comma 64 over e to the 4th. Okay, so that's our parts A. Okay, let's talk about part C. Part C is asking us to find the intervals of concavity and the inflection points. So let's write our f equation again. F was just x to the 4th e to the negative x. And then f prime of x was equal to negative x to the 4th e to the negative x plus 4x cubed e to the negative x, right? And we factored that as well. You can, to find f double prime, which is what we're going to need for points of inflection and concavity, you can either just use this form of f prime, which is what I'm going to do, or you can use the factored form. Either way, you should get the same f double prime. So I'm going to go with this form and think of my first product. So first times the derivative of the second plus the second times the derivative of the first, which gives me negative 4x cubed here. And then I'm going to do 4x cubed times e to the negative x, but then I'll get a negative from the chain rule. So I'm doing now my second product here. And then plus 12x squared e to the negative x, right? So this is f double prime. You want to take the time to clean this up, combining any like terms. These two are like terms, right? So I can do x to the 4th minus e to the negative x minus 8x cubed e to the negative x plus 12x squared e to the negative x. You also want to factor. So I can pull out an x squared and an e to the negative x, and then I have x squared minus 8x plus 12, right? So I've set it up with 3 factors, and I am now going to think about where is f double prime equal to 0, right? So f double prime is equal to 0 when each factor we're going to set to 0 and solve. So the first one is at x equals 0, e to the negative x equals 0 is no solutions. And this last piece is a quadratic equation that factors into, let's see, what would it factor into? Negative 6 and negative 2. And so I have x equals 6 and x equals 2. So these are the places where f double prime, now this sign chart is a concavity sign chart, and I'm making it for f double prime, and I'm going to put 0, 2, and 6 on this sign chart, and then go ahead and think about f double prime. So we're thinking about the sign of f double prime. So my test points are going to be f double prime of negative 1, f double prime of 1, and I'll take f double prime of 3, and f double prime of 10. And that'll cover all my intervals. F double prime of negative 1, the quantity squared, e to the 1, 1 plus 8 plus 12. So this is positive, so I'm positive here. This guy is 1, e to the negative 1. E to the negative 1 is positive, right? So please don't be confused by that. And then I'll get 1 minus 8 plus 12, which is still a positive number. So this is still all positive. So that's interesting. And then For 3, I'm going to get 9 e to the negative 3, which is still positive, and then 9 minus 24 plus 12, and that I believe is, let's see, negative 15 plus 12. This one is negative. And then 10 is going to give me 100 e to the negative 10, which again is positive, and then 100 minus 80 plus 12, which is positive. So my concavity sign chart for F double prime is going to look like plus, plus, minus, plus. Okay, and so now to talk about concavity, we're now talking about the concavity of F, right? So based on this sign chart, I'll change colors here. F is going to be concave up, concave up, concave up, and concave down, right? So my intervals of concavity would be F is concave up on negative infinity to 2. I can combine these two intervals and just state it like that. Union 6 to infinity. And F is concave down on 2, 6. Okay, so that means the slopes on the F graph are increasing on negative infinity to 2, union 6 to infinity. And the slopes on the F graph are decreasing on 2, 6. Okay, and then the inflection point, the only one is at x equals 2, right? Because inflection point is when F double prime changes sign, right? Or in other words, when the F graph does something like increasing slopes and then decreasing slopes, right? That would be our inflection point or point of inflection. So F double prime only changes sign at x is equal to 2 and at x equals 6 in this problem. So x equals 2 and x equals 6 will be our POIs. And we should find f of 2 and f of 6 so that we can properly answer the question. F of 2 would be 2 to the 4th e to the negative 2, which is what, 16 over e squared. And f of 6 will be 6 to the 4th e to the negative 2, which is e squared. And I haven't thought about 6 to the 4th recently, 36 times 36. So I just checked that 36 times 36 out, and I believe it's 1,296. So we can write it this way. So we have points of inflection at 2, 16 over e squared and 6, 1,296 over e squared. And remember, these are points on the F graph, right? The points of inflection. So there you have it, how to find increasing, decreasing intervals using the sign chart for F prime. That's basically the first derivative test. And how to find points of inflection and concavity using the sign chart for F double prime, which is really the concavity test. So hopefully that was helpful. See you in class.